What we're looking at is one of the most concentrated forms of energy that exists on planet Earth. It's the bridge to the future. This is gas hydrate. When we run out of conventional oil and gas, this is going to power the planet.
This gas hydrate is frozen methane bonded with water. It abounds on the moons of Jupiter. Scientists now estimate that the Earth holds more reserves of gas hydrates than coal, oil or gas put together. The trick is finding them. Dr. Sasson is searching for commercially recoverable quantities of gas hydrate.
I can't escape from gas hydrate. It's like my fate, my destiny at this point. I've got to go along that road. I can't escape from it.
The best place to look is deep underwater, where the pressure is high and the temperature is low. Such conditions can be found 150 kilometers from New Orleans, over a kilometer beneath the Gulf of Mexico.
This is a tricky mission. The submersible is good to 3,000 feet. We're diving right at 2,900 and change. There are dangers involved. There is the possibility of entrapment on the bottom. The submarine can get tangled in any piece of gear that's down there that we know about and some that we don't know about. The pressure we're looking at this depth is roughly about 1,300 pounds per square inch. And the temperature, the ocean temperature we've been seeing is about 5 degrees centigrade. So it's pretty chilly. So no, it's not a hospitable place for humans at all. Roger that. All right, Alan, let me know when you get a seal. We have a seal. We're diving. 30 feet.
It takes 40 minutes to descend to the bottom. The submersible has only 3 hours of battery power.
100 feet.
Their destination is nearly 3 times as deep as the most advanced scuba technology can go.
200 feet.
The whole key for us is finding that sweet spot where we've got gas known to be bubbling out of the seafloor and all the magic things happen around the gas hydrate.
300 feet, 300.
Yeah, you need to go northeast, 045 degrees. Come to all stop, drop straight down.
The ship's crew guides the sub using sonar maps.
2,800 feet, 2800, 80 feet off the bottom.
Outside the sphere at this point, you would just collapse in on yourself like a bag of hamburger meat.
We're 75 feet off the bottom.
And now we're going to pan downward. There's the bottom. In all probability, no one else has ever seen this with their own eyes before. You know, the word ocean exploration has some meaning.
Okay, we're on the bottom. Our depth is 2,900 feet, 2,900.
Temperature is 5.4 degrees, 5.4 degrees. Visibility is about 20 to 25 feet, 20 to 25 feet.
If you got a range and bearing that we could try, we'll go ahead and get underway.
Yeah, you need to go northeast, 045 degrees, 260 feet.
bed in the Gulf of Mexico is riddled with small fault lines. It's through these fissures that gas seeps from the Earth's crust.
Most of the ocean floor is the same stuff. Flat, featureless brown mud. But when we come to the gas vents, it's like going to an oasis. A very special spot that's rare on the ocean floor.
Finding a gas vent is just a matter of following the clues.
There's some crabs, lots of crabs that are hiding in the light.
Crabs and other creatures are drawn to gas vents to feed.
It's getting interesting at this point.
They're getting close.
Oh, here's the gas bubbles, look. See those bubbles going up?
Okay, we've got an active gas vent.
The methane is produced by decaying organic matter below the Earth's crust. This gas is a product from the age of the dinosaurs.
We're putting the core tube into the stream of gas bubbles. See it?
If Dr. Sasson can collect the methane bubbles, they may turn into gas hydrate. Trapped at a pressure 83 times greater than that on the surface and at a temperature a few degrees above freezing, the gas transforms into a crystalline substance, pure gas hydrate.
That is the world's future source of energy when we run out of gas and oil.
Where there's a vent, outcrops of gas hydrate must be nearby.
Oh, there's some rocks. There's some carbonate rocks. See that? See those white things? What we're looking at is a huge chunk of gas hydrate.
This turned out to be the largest concentration of gas hydrate ever found on Earth.
That might be a couple of tons of gas hydrate there. Really enormous.
The seabed provides the ideal conditions for a chemical reaction. Hydrates are chemical elements bonded to water molecules. At this depth, the methane is compressed 160 times smaller than it would be at the surface. The gas hydrate located on this dive alone could power a medium-sized city for a year, if it can be harvested. And that's just the tip of the iceberg. In the Gulf of Mexico, there could be enough energy to power the entire United States for 2,000 years. Hydrate-bearing sediments have been found in the Atlantic and Pacific. Some scientists estimate that there are enough gas hydrate deposits to meet the planet's power needs for 3,000 years.
What you want is a big gold nugget. You want energy concentrated enormously in the smallest area possible. And that's what we found, the most concentrated mass of gas hydrate energy that anyone has ever seen. It makes it probably the most significant dive in my career.
Finding rich deposits is just the first step on a long road. Scientists must learn how to extract gas hydrate without harming marine life. And there's another hitch with this seemingly rich source of energy. Like all fossil fuels, hydrates emit greenhouse gases when burned.